Hello and welcome everyone. I'm Erin McNabb, class of 2006 and Associate Director in the Office of Alumni and Parent Relations. I hope you are all doing well and you and your families are happy and healthy. Welcome to our 90s MUDX talks, which are like shorter, more lighthearted TED Talks. To start off with, we would really appreciate if you could all rename yourselves with your class years. You might see some familiar faces, but it's always helpful to have those years as well. The beginning of the event will be recorded and sent to registrants shortly following. But if you're worried about being recorded, again, you can turn off your video for the first part. After the presentation, we won't be recording the general chatting, so you can turn your camera back on for that. We'll be using the spotlight feature of Zoom, so you shouldn't have any difficulty seeing who is speaking. To keep these presentations moving along, we will not be doing questions following each presentation. Instead, we suggest you type your questions into the chat, either directly to the speaker specifically or to everyone to see. And the presenters can respond in the chat after all the presentations are complete. So with that, and without further ado, I'll hand it over to my co-host, Daryl Young, who put all this together, class of 1996.
Oh, thanks, Erin. It was a joint effort, really. But thank you. Welcome to everyone. It's so great to see very familiar faces and to have a little gathering. First thing I wanted to say was just a great, deep appreciation to all of the people who volunteered to speak, especially for the first time we've done something like this. You signed up to do something a little unusual. So thank you for being brave for that. I really appreciate it. I wanted to remind everyone that, as Erin said, feel free at any point to put questions into the chat. Unfortunately, we won't have time for the speaker to answer those questions directly after their talk, but we'll try to save time at the very end for us to have a general Q&A and also some chit chat. But don't wait until the end of that person's talk. You can just put a question in the chat at any moment that you feel appropriate. And also, this is a no judgment zone for video, so please feel free at any point if dinner has to get put on the table or whatever has to happen. Feel free to keep us in maybe on audio, but you feel free to turn your video off. No judgment whatsoever. All right, so without any further ado, we're just gonna launch into our 7 speakers who have so graciously given their time to prepare something to share with us. We're gonna go in alphabetical order by last name, except for Dan requested to go early, so I hope you don't mind. We're gonna just put you on a spotlight, Dan. So Dan Shapiro, class of 97, please take it away.
Thank you so much for having me. And I'm sorry I'm gonna have to drop out after just a little bit because I do have to put dinner on the table. We are at this lovely Airbnb for the week out on the Washington coast, and I'm in charge of dinner for the night. When we were thinking about topics and stories in particular, there is this funny long arc of mud that connects what I'm doing right now to what happened so many years ago. And I thought I'd share that. I've been told I have 5 to 10 minutes, so I will try and make this all fit in that time. So my mud journey started, I would say the second day that I was at RV Mud. I wandered through the dorms and heard, I think it was Pink Floyd playing. I looked through an open window and saw a red laser dot bouncing around on the walls. When I was in high school, I'd worked at the Oregon Museum of Science and Industry. I'd worked in the laser lab, so I was immediately entranced because lasers are cool. And so I stuck my head in and knocked. And Jeremy, who I saw here with us today, was the inhabitant of that room. And I asked him what he was up to. And he'd taken an old woofer cone from a speaker and glued a tiny little mirror to it and had reflected the laser off of it. So moved back and forth, it bounced the dot around on the wall. We got to talking, and Jeremy knew a great deal more about lasers and how to steer laser light than I did, which was very little. And started talking about how to do that. And I was fascinated, and I glue a mirror to a speaker cone too. And we wound up spending some time at the Jeremy, maybe you remember, throw in the chat, but at some local place that had spare helium neon lasers that were scrapped after being used in the lumber industry because they were using them to level stuff. And so we bought them on the cheap and wound up building laser shows. And a couple of things happened. One was, I think it was Leo Dirac came by and saw it and said, "Hey, I'll pay you $50 to go do that at a party at Lynn Dorm, Wacky Willie's surplus." That's right. And it said, "Well, that sounds pretty good." And then we did that a couple times, $50 to go show lasers at somebody's party. And then somebody said, "While you're here, why don't you play some music?" So Jeremy and I agreed to do that. I think we got paid $150 for the first one, took that money that we got paid in advance and went to the record store and bought that much music, which was just exactly enough to fill up the time necessary for that show because we didn't own any music. At some point, somebody suggested, we were talking about names, and somebody, I think, dared us to name the company Fifi. So we named it Lasers by Fifi. Carl, you might have been the one who actually dared us to do that. And then because we had this great sort of arbitrage opportunity of buying these cheap lumber industry lasers at Wacky Willie's and these cheap galvanometer scanners and bolting them together and selling them, we wound up selling laser displays on displays, I mean, used loosely, but these cool, laser shows on the early internet, on eBay and Usenet and the like, for, I think we marked them up like 50%. So we'd spend $100 on the parts and screw them together and sell them for $150, which is also really my first sort of serious go at entrepreneurship, like very lowercase e, and thought it was just the most amazing thing ever. I wound up spending time trying to like cyber stalk companies that were making laser shows because I was like, it'd be great to go into the laser show industry, and they didn't really want anything to do with me. And Jeremy and I researched and looked at all this, and I thought really seriously on graduation, like, is there a way to start a business for a company making laser shows? And concluded that was probably not a good idea. So I wound up going to Microsoft and being a program manager working on Windows and building stuff in the garage in my spare time and building, some laser stuff, some random stuff. And then for the next 20 or so years, my day job was always software, and I would come home at night and build stuff. After electronics for a while, I decided I was going to build a wood shop because I missed the shop at Mud. And so started acquiring all sorts of wood shop equipment and putting it in the garage and everything else, and built a dining room table and a coffee table and boxes and all sorts of other stuff. And it was piles of, yes, we appreciated it. And, piles of sawdust, but it was always, half an hour to set up and half an hour to clean up and woodworking in the middle. And so when our twins were born 12 years ago, that came to an end. And I started building RC airplanes and drones because I kind of walk up, play with them for 15 minutes, and then walk away and leave things in a state of disrepair. And the kids, even at a very young age, liked going to the park and watching them fly. So I wound up starting a company that did mobile images for camera phones, wound up starting another company which did comparison shopping. That company was acquired by Google, spent some time at Google, and I took a leave of absence from Google to do two things. To write a book about startups, which is called Hot Seat, the Startup CEO Guidebook, published by O'Reilly, and to take a game that I invented with my kids called Robot Turtles, which is programming principles to kids as young as preschool. They were in preschool at the time, and to turn that into a real thing. So I launched this Kickstarter campaign for the game, and it turned out to be a big surprise success. Me surprised most of all, because it really was just this kind of like fun little side thing, and then it wound up blowing up. And in the middle of that, I wound up having drinks with a good friend. Thank you. With a good friend who said he worked at Boeing, actually a Boeing subcontractor called Exotic Metals. And he said, my son thinks that the game is really cool, and he wants a turtle that he can like grab in his hand and stick in his pot and get all sweaty and grimy. And like, you should do a special edition 3D version of Turtles. And I was like, ooh, I have been wanting an excuse to get a 3D printer for ages, but I kind of get the impression that they only make plastic tchotchkes slowly, and that doesn't seem very attractive. And he's like, yes, consumer 3D printers are universally terrible, and they're lousy for mass production, and the industrial ones are expensive and slow, and like, that's not what you want. And I was like, well, okay, take me on a tour of the shop, because you've got all the tools at the shop, or like, talk me through what's there. And he started talking through all the shop tools as I was thinking about how I could do a batch of like 100 special edition turtles. He's talking about the plasma torch and the water jet. And I'm like, those are all really cool, but like, I don't want to punch it out of metal. And then he finishes up the whole thing. And then he goes, oh, and the laser cutter. I'm like, lasers? Tell me more. I should note that in the game Robot Turtles, the robots all have lasers on their backs, which was my daughter's idea, but I was pretty excited when she had that. And she says, no, it wasn't. I'd still give you credit for it, but okay.
Give me credit.
So Hans says, give me credit. So I'm like, lasers, tell me more. And he's like, oh yeah, we'd use it for basically nothing. But after hours, all the folks in the shop come by and use it because it's really great for small batch production. And because you're cutting stuff, because it's subtractive, you can have something that's full color and you can do that. I was like, this sounds great. So into the local makerspace, started playing with it. They charged $4 a minute, wouldn't let me touch it. It was terrible. I wound up with this industrial carbon dioxide cutting laser, the size of a coffee table, installed in my garage, imported directly from a factory in China, installed in my garage, making a bunch of turtles. And it was terrible, and the design was awful, and maintenance was a bear, and the software was a disaster. But it was that magic that I was looking for, because you could push a button, and it would steer the laser around, just like the good old days, and actually create something that was exciting, and that was beautiful, and that was creative. And that's where the company Glowforge came from. And it is shocking to me how often in the course of now operating the company, which is almost 150 people, and we're up in Seattle and busy making beautiful desktop, as we call them, 3D laser printers, but CNC laser cutter engravers for everyday folks that are easy to use and delightful. I go back to my email correspondence with the CDC that I did in college about laser safety stuff, because we wanted to be legal with our lasers, talking about power supply design, which was straight out of the argon laser power supply Jeremy and I designed so many years ago. How all these lines connected, culminating with 18 months or so, give or take, Maria Clave joining our board of directors. And so that's the 25-year arc of lasers from Harvey Mudd to Glowforge to the present. Thanks so much.
Thanks, Dan. All right. Next up, real fast, switching it over to Tanya Carone will be the next one, class of 1995.
Okay, hopefully y'all can hear me. Can you hear me?
Yes, we're good.
Yes. Okay, good. All right, so I am going to talk to you about my pets. I have a shark tank. Yeah, I graduated in 95. Bill is my husband. He graduated in 94. We got married in 95. We're still together. He is not going to step over and poke his head in. I asked him, but he's over in the house feeding our child, who is 16 and old enough to feed himself, but you know, they're hiding out. So I have a shark tank, and this is a picture of the main viewing tank. And so the first question I always get, how big is my tank? Well, when I talked to Daryl about this talk, he said, tell them something that's interesting to mudders. So I actually did the math. Prior to doing the math, I'd say 40,000 gallons. I did the math. It's actually 38,500 gallons. So in addition to the main viewing tank, I have 5 different quarantine systems that are completely isolated from each other. And they range from about 125 gallons to a 1,000-gallon tank. And you can see some pictures of the smaller tanks here. They are all up and running. They all have their own water supplies, their own pumps, their own filtration systems. So it's not just one big tank, it's a lot of tanks to keep this up and running. So what do they eat? Everyone asks me that. They eat fish. They sometimes eat each other. We try to discourage that, but it happens. So you can see that I've got a picture here of them eating some crab, and just my stingray eating some other fish. If you ever get old or sick in the tank, they will eat you. I've watched them take out other fish. I've had clients here and they've taken out a fish during a meeting I was having. But at least it was a small fish, so it was a one biter. It was a quick and gone. Okay, so water attributes. Every week we have to check the water. It is a very large system, so it doesn't go out of whack much. You can see this is 3 months worth of data. The pH is about 8.3. Temperature is about 80 degrees. It's pretty constant. Other pictures you see here, I get salt delivered by the pallet so that I can mix salt water. I mix about 2,000 gallons of salt water a week to put into the tank to help reduce my nitrate levels. Also here you can see a picture of some mangrove trees that are actually growing in my sand beds that I have upstairs. So the water passes through that to pull out some of those nitrates as well. Is it a lot of work? The answer is yes. It is a lot of work to maintain a nearly 40,000 gallon tank. So here you can see my sand filters. I have a bank of 9 sand filters. Every day, 3 of the sand filters will get back flushed, and then we filter that water. Some of it will go back in the tank. Twice a week, the water gets dumped out to my outdoor pond. I have a probably 2 million gallon freshwater pond that's just out on my property. And then there's also a tank here, a picture here of underneath the tank that is just a bunch of the pumps. I always have pumps going out. So yeah, it's just it is a lot of work to maintain this. Okay. Oh, does it leak? Yes, it leaks. So there's a picture here. We did not know where this water was going. We were here and it's like, I'm like, it's a little low. And so then, you know, I got up a ladder because this is near the ceiling. And so we got a dry erase marker and started marking where the water height. So at 5:30 p.m., it was a few inches low. At 10:30, it was a few more inches. At 8:30 in the morning, it was even lower. Me and my children walked around the whole building and could not find where this water was going. So clearly it was going down a drain somewhere, but we did not know where the failure was. We eventually found it. It got fixed. Not a big deal. This other one is a huge deal. So there's a picture of the ceiling of the bottom of the tank. So that's the bottom of the tank from the bottom looking up. We had about 100 to 300 gallons a day coming through the concrete. This was in 2019. It was physically raining in our basements. And there's a picture on the bottom here that the pumps are all covered up in tarps and the ground's all wet. We had to fly people in to fix it. And we actually got bumped because the polar bear tank at the Columbus Zoo started leaking. So they had to go take care of the polar bears before they could come to us. And then what they did is, while the tank was still full, I had a few guys underneath the tank that were drilling holes into the concrete. So it's a 10-inch slab of concrete. They drilled holes 5 inches into the concrete, so halfway through the concrete, and then pressure injected an epoxy urethane mixture to stop the leak. And it was supposed to hold for a year. COVID happened, so I have not flown people out to fix the tank. We actually need to drain it, take all those fish, put them in quarantine tanks. The shark is going to end up outside in an above ground pool. The cougar that's been going through my yard, hopefully will not play with the shark. We'll have to see. If not, I'm going to put a camera out there, so I might have a really good video next summer when this all happens. All right, cleaning. How do you clean the tank? You put on scuba gear. Yeah, it's not, the fish are still in there, the shark's still in there, but this is what it takes to clean the tank. These guys are actually buffing out the tank and redoing all the silicone joints. The silicone joints were fun because they're this black silicone, and then my shark was interested in it and got it on his nose, and then spread silicone all around my tank. So it's like, oh, it was all clean for a minute. Let's see. And that's it. That's all I have. Here's just some random pictures of my shark tank, different views. I used to have 3 sharks. I currently only have 1. The shark's name is Clyde, because it used to be Bonnie and Clyde. My rays all have ray names. Right now it's Charles, so I have Ray Charles. Used to have Sugar Ray. But yeah, we have very few fish right now, again, because we're getting ready to empty it to repair the bottom. We're going to have to reseal. We're going to relay some more concrete, reseal it, and do all that good stuff. And then I am going to have to book off at 6 o'clock, kind of like Dan. I've got something else I have to get going and doing. But if you put any questions in the chat, I will try to answer them before I leave.
Amazing. By the way, anybody who wants to spotlight, just go click on Tanya's video and you can make that the spotlight so you can look at the tank behind her if you want to just look at that all evening. Our next speaker is Kathy French, class of 97. Welcome.
Sorry, was having to get my screen shared. Thank you. So I'm going to talk about work because right at the moment I'm pretty much living work 24/7, 365. And one of the biggest challenges I've got is helping New York transform its power grid into being 100% green. And now I'm trying to figure out how to, oh, there we go. So 4 years ago, my company bought the Ravenswood generator. It's right on the East River in Queens, New York. It's about 2 gigawatts. During Superstorm Sandy, it provided by itself 55% of New York City's power. So it is a massive power station in New York City. The third stack in from the right is, it's called Big Alice. It was the first greater than 1,000 megawatt boiler in the world. The only boiler built by Alice Chalmers. They then stopped it. And so, you know, it actually has its own Wikipedia page. It's so famous in the industry. So anyway, these 4 stacks are very prevalent. Any New York City TV show, most movies, you see our 4 red and white stacks. Every time you fly into LaGuardia, you can pick them out perfectly. So I've owned this power plant for 4 years, or my company has. And in 2019, the Governor Cuomo passed a law saying 70% of all power is going to be renewable by 2030. So I have this hundreds of $million investment in a power plant that is going to be obsolete by 2040. So it's the, okay, what do we do with it? So the first challenge is to understand what goes on in New York State. So upstate New York, as you can see by the upper left, is 90% renewable. They've got so much hydro from Niagara Falls. They've got solar, there's upstate wind. So upstate New York absolutely does a wonderful job. Downstate New York and New York City is 77% fossil. And so in order for the state of New York to meet their goals, you've got to fix downstate New York. And the little yellow section of the state is what they call transmission constraints. There aren't enough transmission lines to help get all this green energy from upstate New York down into downstate New York. So one of the solutions that we have come up with as LS Power, and it's Rise Light and Power is the project that owns Ravenswood, it's a sub company, not important, is to build a transmission line that takes you just inside that yellow constraint, brings all the power down the Hudson and brings it into New York City and taps into my transmission rights at Ravenswood. And that way we can slowly utilize that, you know, sits on the river, phenomenal infrastructure, so heavily contaminated, you can never do anything else with it. So it's a way to take this industrial piece of land that sits on the river and help utilize it to take it green. But the things I have learned in the meantime, I have a cool picture of fish too, Tanya. This is an Atlantic sturgeon. So the sturgeon, both the Atlantic and the whichever other one, are both endangered. They live in the Hudson River. They, between their spawning, breeding, and foraging seasons, you can only do construction in the Hudson River in September and October, and they might let you stretch to Thanksgiving. So very tight construction window in the Hudson River because of these wonderfully lovely fish. And then the thing I have learned most recently is sturgeon utilize the Earth's magnetic field in order to forage and breed and figure out where they're going. So they have this little internal compass built in. Well, you can't build an AC power line that's over about 115 miles long. I've got 115 miles just in the Hudson River, so I need to build a DC power line. Well, a DC power line doesn't emit EMF, it just does a magnetic field. And depending on if it's laid, in direct line with the Earth's magnetic field, it intensifies that signal. Or if you get it cross to the Earth's magnetic field, it confuses things because it's weakening the natural magnetic field or creating a signal. Obviously we've all done vectors. So I have spent the last 2 months learning all about how much I have to shield my DC cables in order to bury them in the Hudson River so that my wonderful sturgeon will still know how to find dinner. So, one little thing of, I did have a subtitle on this of thank goodness for the Corps. Here was biology lessons, here was E&M physics lessons. The other challenges that I'm dealing with as me and the team work to try and figure out how to lay this cable down the Hudson. There's PCB contamination from the industry in the Hudson 100 plus years ago. You cannot get that sediment back up into the water column because PCB is highly carcinogenic, and there's drinking water intakes all down the Hudson River. Not to mention, if I get it back in the main water column, the fish are going to eat it, and that's not good for them either. DC cables also have heat, so we are presently, come September 1, again back to the sturgeon seasons, going to be taking samples to figure out the heat dissipation properties of the muds in the Hudson River all the way along to know how do we have to shield it so that I get enough heat dissipation to not melt my cables. Then the Hudson River is still an active shipping channel. There are anchorages during fog season where they, drop anchor. And so how do I place my cable to get it out of there? DC cable's in high demand. There are offshore wind farms all over the world. And so you actually have to put money down 2 years in advance to get in the manufacturing queue to be able to get DC cable. There are gas pipelines from the last 150 years all over. So we're actually doing magnetometer surveys of the river right now to get basically grids of where all this stuff is laid so we know how we have to cross it. Reliability, we do not need Texas or California brownouts in New York. So what do we have to do to make sure we've got 4 cables all running in parallel so that if one breaks or we get a fault in it, we can shunt the power to the other line and keep power running downstate. The most fun, there are also lots of shipwrecks on the bottom of the Hudson River that we cannot disturb because they are considered archaeological artifacts and critical to our history of the Hudson River, despite the fact they're buried. And you can't scuba dive them, but we can't mess with them either. And then finally, we run through areas like the Bronx and Harlem, in which these communities have borne the brunt of years upon years upon years of people coming in, and they have no access to be able to walk along the river. So as part of our project, we have to figure out how to try and help get them the same benefits as the hundreds of millions of dollar homes that are on the other side of the river. So quite the challenge underway. that's all I've got. Hopefully next year I will have more to say and say, hey, we're getting ready to lay cable. But anyway, thank you. I'll answer questions in the chat.
Thanks so much, Kathy. Up next, we have Carmen Lee, class of 94. Take it away, Carmen.
Thank you, Erin. Good to be here, everyone. And I've been enjoying the presentation so far. And we're shifting gear a little bit now. We are focusing more on the human emotions and connecting with our body. So drop the technical stuff for a while. And so my work is really about helping people rise above their circumstances or be more resilient. So when we're more resilient, it's probably a big word these days since COVID, we're actually more able to tap into that wisdom, the insights that we have, and new ideas. And innovation and creativity is really important, especially the time that we're in. When it comes to resilience, what I've noticed is that there are people who think, well, resilience is about just to get it done no matter what happens. So I'm just going to move through it, whether it's COVID, maybe I have family issues, I'm just going to work through this and things will just work out. Or I'm just going to be very positive in my thinking. And if I ignore these unpleasant feelings or stressors, it will just go away. And what I've noticed over time, it doesn't matter the level of intelligence that people are, over time, these unprocessed experiences and emotions just keep shoving in the closet, and they keep piling up in the closet, and they close the door. And eventually these unprocessed experiences that is overridden by positive thinking start to creep up and affecting people's health, their relationships, and probably finances. And so what my experience is telling me that it's actually really important to connect with our feelings, no matter how unpleasant they are, because they bring great gifts. And so to give you an example, recently I have a woman, she's in her 70s, and she was telling me how she had been struggling with her husband. They've been married for decades. And she was like, well, we're going separate way. And I'm at the age that I don't see myself divorcing him. And it's just a matter of how I orient myself in the situation that I am in so that I can get the most out of the relationship. And she felt a lot of grief in her when she was talking about it. And she was like, oh, I'm probably going to cry a lot after I finish talking to you. And I walked her through a process, which I'm going to do a very abbreviated version with you shortly after this in this 10-minute window, so that you get a sense of how it is. And after I walk her through the process, she moved her grief was at a scale of 7 on a 10-point scale, from 7 to 1. And it was a very quick process. And when I asked her, so how are you now? It's almost like, it's like, what? I don't remember how I felt back then. It just dropped away. So that's the possibilities for a lot of us, all of us actually. And the interesting thing is that, remember I was talking about how unprocessed emotions and feelings that we don't want to feel, sometimes we shovel them in the closet and close the door and think that we don't see it and it'll be taken care of. What happened is that a lot of the current emotions that we feel about current situation, it might seem like it's related to the current situation about COVID, about the work situation or marriage or whatever, but actually is related to longer term issues. So for this particular woman that I was telling you about, she's 70, right? So when I walked her through a process, a more deepening process, she actually connected to an experience she had when she was 5 years old, and a simple interaction between her and her mother. So it doesn't need to be like trauma or anything, traumatic. It can be just simple things. Like for me, my dad used to say to me, like, Carmen, you're so emotional. That was when I was really little. And at that moment, I decided emotions are just bad. And so I'm just gonna not deal with my emotions until life told me to deal with my emotions. So here I'm talking about emotions with you now. So when we are able to connect with the emotions, like this woman I was telling you about, once you open up, meet the grief, feel it, connect it with her body, she starts shifting. And then all of a sudden, within a day, she basically told me, oh, I think I know the way to move through my relationship with my husband. I actually see a new way through now. So when we're able to meet what we're not willing to experience because of how unpleasant it might feel, we're actually allowing greater insights and capability within us. So I'm going to walk you through the process now. And if you are open to, you can close your eyes if you're more comfortable. It's just going to take 2-3 minutes since we have a short period of time. So just to redirect our focus, to shift our attention from the mind to closer to our body, let's take a couple of nice deep breaths in. And as you inhale, breathe into your belly, dropping your attention from the head, from your mind, moving that breath through your nose and allowing the breath to go down to your body. Take a nice deep inhalation and extend your belly. Take a nice deep breath in, allowing the breath go all the way down to your belly. And as you exhale, relax and release the breath, release any tension, all the information, the data, the images that were shared. Let it all go because it'll come back to you when we're done with this process. And breathing in one more time in your belly, deep breath in, relaxing your whole body, dropping the shoulder, dropping your face, relax your face, relax every single part of your body, allowing you to feel in deep into your belly as the inhalation recharge you. And on the next inhalation, think of a situation, the first thing that comes to your mind that might stress you a little bit, maybe an interaction with somebody, there's some tension with somebody or a work situation or something that you had to do that cause you feel a little anxious. Whatever that is, just connect with that. Or somebody said something to you, whatever that comes to you, and connect with that. And notice the feeling. How does that make you feel? And breathe into that feeling, acknowledging, welcoming the feeling, as if it's a friend that wants to connect with you. And as you experience the feeling triggered by this event or person or situation, feel the feelings and notice where it is in your body. Notice where it carries the strongest charge in your body. You might feel in different places, maybe all it comes at once, but just connect with that part of your body that you feel the strongest charge. If you don't connect, you don't feel anything in your body, you might still be in the mind. So I encourage you to continue to take deep breaths in to get more connected with your body. But you notice there's a strong charge. For me, usually it's in my chest, could be in my shoulder, wherever it is. Just breathe into that particular area. Welcome that sensation, allowing your breath to merge into that area where you feel the strongest charge. And breathing that in. And you can even visualize that you are giving a gentle hug to that part of your body and telling that part of your body, that feeling, the sensation, that it's okay. Because you have the power to connect with what needs to be done, how the situation can be handled. And breathing that in one more time, connecting with that feeling one more time, and thanking this body part and this feeling for showing up at this time when we are here. And you can even make a promise that you will come back and revisit with this feeling or the body parts that wants to connect with you. And take a nice gentle breath one more time to that part of your body. And exhale. And breathing into your front chest. Nice, easy breath. And just by breathing in slowly and gently, you're already shifting your state. And when you're ready, you can open your eyes. And just notice if there's anything, any insights, any shifts in your being. If you want to stay there, then you're welcome to, of course. And so this is a very abbreviated version of the process I usually work with clients on. But the main message I want to bring you is that our mind can tell us a lot of things, but we do really need to connect with the body. And exercising is one thing, but feeling the sensations in the body, connected with the emotions, is the key to greater presence and awareness within us. And with the presence and awareness actually brings great wisdom, and you will gain a lot of insights about yourself or situations and how to handle it, as opposed to just researching and thinking it, because you do have a lot of insights within you, very deep within the mental chatter. And so that's what I'm offering today. Yeah, you're welcome to type in your chat about your experience if you like.
Thank you, Carmen. I really needed that today. I had no idea that was about to happen, but I really appreciated that. Thank you. All right, let's welcome Hannah Ma next from the class of 94.
Hi, everybody. I want to do a shout out for my friend Carmen, who just presented, and then my good friends Jenny and Christy, who are here watching and listening. So I am a STEAM coordinator at Contra Costa County Office of Education. I've been in education ever since I graduated in K-12 education. And I want to share with you about equitable grading practices and the movement towards that in public education in California. So I'm going to go ahead and share my screen, but before I do that, I want you to think back to your high school days, go all the way back years and years ago. Or if that's too hard for you, maybe you have a middle school or a high school child, think about their high school experience. And in particular, think about the grading policies of a high school course, okay, the grading policies. So I'm gonna go ahead and share my screen real quick. All right, so the typical grading policy is something like this. This may look familiar to you. You have, can everybody see the screen? Yeah, all right. So it may be based on a 0 to 100 point scale. Obviously, this is not on a curve, it's not mud, where you have A, B, C, D, F, and they're loosely based around these grade groupings, homework, tests, projects, etc. Okay, so this is kind of standard across various subject areas. Now, what is different is within this, each teacher has autonomy about how they're going to kind of work with. In terms of weighting in particular, teachers may have very, very different kind of weights that they place on each of these grading groups. So for example, here's teacher X, here's teacher Y, here's teacher Z. And how they place the weights on these grade groups is reflective of their beliefs about what grades mean. So for example, teacher X is putting a lot of weight on homework, projects, class activities. And so this teacher is probably believing in like career readiness, work habits, effort. Whereas teacher Z is, no, the kid needs to learn the content and needs to show mastery of the specific content area. So tests are going to be worth more. Teacher Y just goes, well, everything's equal, okay? So they may have very different type of beliefs about what grades are reflecting. And even more, within an area like homework, teachers may vary in the way that they give points. It could be based on completion. You get full credit if you complete it. Or another teacher might say, no, it's on accuracy, right? You can only get full credit if it's 100% right. So it's just a lot of variance. So what does that mean? If you are a student in this class, in these classes, you may be more likely to get an A in teacher X's class, even if the course is the same across. And teacher Z's class, it may be harder to get an A. And you know what? Kids know this. They know who they want as their teacher for, you know, calculus. It's like, oh, I want that teacher because they grade not as harshly. So who is right? Well, let's take a closer look. So we're gonna think about two types of students being in these classes. One type of student is Tangela. She is the teacher's dream. Okay, you would love to have her in your class. She is respectful, she is kind, she's a leader, she is helpful, She does all her work, right? But not all of it is right. She has a difficult time understanding the concept, and she has extreme test anxiety, so she does very poorly on tests. That's Tangela. And then there's also a student like Isabel. She is the teacher's nightmare. She has an attitude. She's disrespectful to the teacher. She hardly ever completes her assignments. She doesn't show up to class, but she learns the material very quickly and she aces just about everything, right? So think about these two types of students. We have Tangela, we have Isabel. If, there was a parallel universe in which a version of them could be in class X, Y, and Z simultaneously, what grade would they get? So if we had more time, I would actually have you explore the simulation gradebook, but I just did it for you because we don't have that much time. So for Tangela, she might receive out of 100 points, these kinds of points, like 60 out of 100 on tests, but 100 on homework, etc. So for Tangela, she's gonna get a B in teacher X's class, whereas she would get a C in teacher Z's class. How about Isabel? She's gonna fail. She does really well on tests, but she's not doing her homework very much. She's gonna fail in teacher X's class, whereas in teacher Z's class, she's going to get a B, okay? So who is right? Which grades are correct? Which are fair? So the problem with traditional grading is just this. I kind of highlighted number one, it varies from teacher to teacher, but it also is not often accurate, right? And it's infected with bias also. But this is a necessary evil that our high school students especially have to live with because grades matter for them as they matter for us, right? It matters for college admissions. It matters for scholarships. It matters for awards. It matters for graduation, etc. It matters. So within these parameters that it does matter, what can we do? All right, what can we do? So the movement, like I said, in public education is going towards equitable grading policies. And what does that mean? It means this. The emphasis is on the learning. It's gonna be hard, but it's possible. So the teacher is not the judge and jury who's like, I'm gonna give you points if you do this. No, but they're more of a guide. And the emphasis is on learning rather than points. A lot of students think of school as a game of grades, right? But really we need to shift that focus to learning. Competence over compliance and feedback as a tool for learning from the instructor, from the teacher, rather than the grade itself. So what do we do? Like, how do we get there? So I have a short little video for you that kind of illustrates it in skateboarding. So go ahead and take a quick look. All right, so that's my nephew, Adrian. And he is going to be a physics teacher. He's right now in school. And that's his next step. But anyway, did you get that? The connection to learning and skateboarding? Well, there is such a person who is a skateboarder and who is a physics professor who did a TED Talk on this. And here are the lessons that has the connection between, skateboarding and learning. Take a look at these points. Failure is normal. And take a look at the third one. Work your beep beep off until you figure it out. And learning, the process of learning is not really fun. Like, it's painful, but you're motivated to keep going until you get there. And then you just go a little bit more, a little bit more, a little bit more, right? So these are the lessons that we need to be placing into education. So what is happening in education? So I get a little bit more of a glimpse on what's happening statewide. This is California Department of Education's webpage on grading student progress. So in this COVID-19 pandemic, it has called attention to the inequities that students are experiencing that we really didn't know too much about. We see inequities in access to virtual learning, including device, Wi-Fi, etc., as well as grading. So grading has been a big topic during the pandemic. Some students just were not able to be successful, and there were so many D's and F's throughout the state. So this webpage has information about how schools and districts can kind of shift the focus to be more equitable in their grading. And there's some districts that have been doing this work, like San Diego Unified is one of them. And finally, I'll leave you with this. If you are interested in learning more, this is the book from which I got a lot of my learning from. This is Joe Feldman, who's been doing the training on equitable grading practices. And this book is called Grading for Equity, What It Is, Why It Matters, and How It Can Transform Schools and Classrooms. Thank you.
Thanks so much, Hannah. Next up, we have Frank Schmidt, class of 97. Take it away,
Hello.
Frank.
All right, can everyone hear me?
Yes.
All right, let me share here. Let's do this window. So I have a hobby project that is micromobility, which is kind of a name that someone coined for these small electric vehicles, e-bikes, bikes, and those scooters that everyone hates. So my project is a skateboard that's motorized and has little weight sensors under the front and back. And so you just stand on it and lean, and then it kind of takes you off to where you're going. So why did I do this? Actually started this shortly after MUD, and you could not buy something like this. In the meantime, there's a bunch of people that have sort of tried to build one and have sold them in some cases, but it's still a fun problem. This was a tweet I kind of like. I think it applies to engineers too. It's just always fun to fix a problem like this. And then, hold on, I'm having a little trouble with advancing here. So it uses lots of things I learned at MUD. So my day job is mobile app software, but there's lots of cool stuff I learned in school, both at MUD. I actually did a postbac in vehicle design just across town here at Western Washington University. So it's fun to apply some of that. So just a few like interesting problems I ran into and kind of how like MUD education helped with them. The first thing is turning it on. So if it's always ready to go, you set it down and you step on it, it's going to take that 1 foot at a time, because you're not just going to jump on it, as a weight difference and take off on you because it doesn't know that you're not fully on it. So I have this little like kind of a state diagram. There's a bunch of different states. The two that are kind of interesting here are these two transitions. You probably learned, finite state machines in CS class or whatever. But I was thinking like, how do I transition from this, like you're standing on it, but you want to go, and originally, like way back in the day, I had a little like keychain remote like you'd use for your car. But I decided that a cool way to do it would be to just do like a little like bounce gesture. And then the same obviously for going the other way, just in case like some random sidewalk cracks line up just so, and it misinterprets that. There's a speed limit, so you have to be almost stopped to go back into the braking state. But I was like, how do I do bounce detection? I thought maybe some like machine learning or some like, high-tech computer science kind of thing. But what I ended up doing is just recording the bounce. So you can see here, there's like a little bit of a dip where you're kind of picking up your legs, and then there's a peak where your weight is on it, and then it'll rebound. So what I was able to do is just record this and then run a correlation, kind of a convolution between the input and this. multiply and add all those together, and then you get this one number that kind of blows up anytime the samples look like this waveform. And so I can just basically do an if-then statement and do those two straight state transitions. Ironically, I have to debounce this so that it doesn't get triggered a ton of times in a row, but that's fairly straightforward. Control theory, there's sort of this classic problem, which is balancing an inverted pendulum on a control system. Usually that's the control system keeping the pendulum balanced. In this case, the pendulum is trying to make the control system like run to the store for milk. I ended up like not really figuring out a good way to model this, and sort of just like tried to eliminate weird sources of error from the inputs and just kind of make the control as natural as possible. I swear, like I wrote this slide and I did not realize this author was a mudder, much less was going to present right after me. So I just figured I'd lean into the coincidence here. So I'm paraphrasing this quote from a book, which is like, all weight sensors are torque sensors. So the weight sensors that I'm using on a skateboard, you steer by kind of rolling the whole thing from side to side. So you need something that's really stiff in that roll dimension, which means you kind of want a hinge, and a hinge really senses torque potentially as weight. This is what they look like. This is kind of the high-end version of a hub motor. And there's this little suspension truck. And right in here, there's a little strain gauge. And so you can tell when this thing would rotate really forcefully, it would cause some deflection here. And so fortunately, you can kind of measure that and account for it. So this is kind of a linear plot of current on the x-axis versus force on the y-axis. And you can just kind of take that slope, figure out how much current you're sending to the motors, and subtract that out from the input signal. So that was kind of using that motor constants from electrical engineering. The last problem, weight transfer, this is actually a little bit more into the vehicle design side of things. And so you're riding along and something comes out that's in your way. You're like, oh, I got to slow down, got to come to a stop. And you lean back, and to apply some braking force, the motor will start actually regenerating electricity, which slows you down. But that causes, because your center of gravity is pretty high and your wheelbase is pretty short, it causes a lot of weight to then transfer onto the front truck. And the front truck is what you use when you don't want to brake. So it cancels out a lot of your braking signal. But once again, because we know what the current is, we know what the forces are, the skateboard can do a little math and actually cancel out that little error, and the squirrel lives to see another day, and so does the skateboarder. So those are just kind of a few things. I had to cut some things for time, but what did I learn? It's really fun to do these sort of projects where you can kind of be a generalist. Oftentimes, if you're doing things for work, people want to hire a specialist for this one little narrow area, which is kind of what my day job is like. So this was a fun little diversion. Like I said, I've been working on this for like 20 years, and things were really primitive and hard and expensive 20 years ago, and they're really a lot easier now. The batteries, motors, and controllers are all amazing, and you can order cheap ones from Amazon Prime and have them like 2 days later. Software, so you can get embedded compilers, you can get printed circuit board design software, and even like CAD programs, often just like in your browser for free on the internet. For hardware, like I said, I made some little strain gauge amplifier boards, and it was like 100 of them for about $20, delivered in a week or two. I had to make some adapters. There's commercial suspension trucks and commercial motorized trucks, but you can't buy both in one. So I had to do some adapters. I was able to design that in an online CAD program, send away for it 6 weeks later as I had the parts. And lastly, you kind of never know when you'll end up using some little bit of knowledge that you learn in class. So that is it. Thank you. I have a little like Twitter account that you can follow that I kind of post occasionally about this stuff, but thank you.
So cool. Maybe we'll ask you later if we can see you writing it. That'd be cool too.
All right, yeah, we won't record that.
All right. Well, last but not least, let's welcome Alicia White. Class of 96, yay.
Hi. Okay, so you can see MudX 90s talk. Okay, let's get to the good stuff. First, these slides are available, as are the origami patterns. And you must provide your own paper. And if you're working with live snails, you have to provide your own snails. Actually, it's just the shells. And I need to start with some terms, sorry about that. But first is planispiral, which means it curves in on itself like a nautilus. It's in a plane, planispiral. The other thing is turbinate, and this one is turbinate, as soon as I find myself, where it goes up. It's conical, it's shaped like a turban. Revolutions are what they sound like. They're going around. And whorls are the physical representation of the revolutions. There we go. The protoconch is this, the tip, the apex. That's the first shell of the baby snail. And the body whorl is the big part, the last whorl. And then the opening is the aperture to the outside. Okay, so enough vocabulary. Why are shells interesting? Biologists need a way to describe shells, mainly so they don't name one after their kid, only to find out it was already described by somebody else. David Ropp provided a way. The first idea here is that circle. Those circles over there, they're generating curves. They represent the shape that the whorl opens into, the aperture. And I'm not going to read what the parameters mean. The two you need to know are W, which is about how fast the whorls get bigger, and T, which is about how much the whorls get covered as the shell grows. So going back to our terms, planispiral, like the nautilus that curves in on itself, has a large T, where a turbinate or conical shell has a smaller T. And check out the paper name here. He did this in computers in 1962. Imagine this poor paleontologist with a box full of punch cards. But he didn't stop there. He went even further. He graphed fossil shells and how they worked with his description method. And he showed that nature has tried many of the options in the parameter space with some success, some not success. And I could totally go on about how nifty this is, but I need to move on to paper. I liked origami, but it wasn't an obsession until about 2 years ago, when I needed to fold a really good origami cat so I could add an electronic purring mechanism. I folded hundreds of cats. I started to understand that origami isn't about successfully folding a 57-step dragon once, but folding the dragon over and over again until you understand it. It turned out to be a lot like calculus. And somewhere in there, I found curved crease origami. The results are so otherworldly, beautiful, and always three-dimensional. Computer science hero David Huffman of Huffman Codes was big into curved origami. The curves, they have to be precise, so they tend to be computer generated. And in order to get a sharp curved crease, you have to pre-score the paper. Thicker paper like cardstock is easier to pre-score. And I initially did it by printing out the patterns of interest and then pressing hard with a ballpoint pen to get the grooves, the score into the paper. Eventually I got a Cricut. It's a machine that does it for me. By this point, I was looking beyond folding patterns other people did and thinking about designing my own. The octopus pattern isn't too difficult. I don't think. I've folded a lot of them at this point. And other people have successfully folded them, so I think it's okay. But when I did this, I wanted an origami aquarium. And then my husband, Chris, also 96, gave me a book as a present. Tomoka Fuse is a super famous origami artist. You're gonna have to take my word on that. She does a lot of things with spirals, has a whole book about them, and another book about spirals and boxes, which is super nifty, but not on topic. Anyway, she has this navel shell pattern and many variations upon it. And I think it was this page that did me in. angles, triangles, modifying geometry to get different physical structures. At the top of the triangle, there's this thing called a central angle. And a larger central angle leads to a larger body whorl and a smaller protoconch. The spirality angle, the smaller angle near the bottom, causes the spiral to grow more quickly, leading to bigger but blockier and less rounded forms. But remember back to Raup, when he described W, which is how fast the shell grows, and T, which is related to how much of the old whorl is covered by the new. So I wanted to reproduce the patterns from the spiral book. And I'm accustomed to the pre-scoring with straight lines, makes them easier, especially if they need to be precise like these do. So for pre-scoring, I needed to make vector files, SVGs. I knew Python, and I used NumPy and Matplotlib a lot for data wrangling for my gadgets. But it's been a long time. How do you make a triangle with a bunch of horizontal lines and some more triangles inside? I had 2 of the 3 angles. Eventually, I figured that out, which meant I could get all 3. I had to choose a length, and everything else fell out from the law of science. Once I remembered that was even a thing. After I had 1 horizontal line with its 2 triangles, I could go down to the next and the next and so on. And I'm not going to go over the code with you, but I will say it's in a Colab, which is a way to intersperse code and text. It's like a Jupyter notebook, if you've ever heard of those, but you don't need to have heard of those. It's online, so you don't have to install anything. You can run it in your browser. And I mean, my code is kind of readable, but in the end, you could just push the button and get the pattern. You don't need me at all. So mission accomplished. We have patterns that are easy to generate. We have a pattern, a snail folded from the pattern, and this one's boring. It's all folded in on itself. But the fuse method, you pull out the protoconch, you pull out the little top part. And then ever after having pulled it out, the protoconch, it's harder to fold the whole thing. So snails shouldn't be flat. They should be conical. They should be turbinate. Flat snails is a sad blues song. So it seemed like there might be a better way. What if the central angle wasn't balanced? What if the spirality angles weren't balanced? Why do I spend so much of my free time doing geometry? It turns out evolution is cruel, and there are many parameters that do not work. This, by the way, is why I needed to learn about Raup's shell description method to figure it out. Some parameters do work. Here is the spirality angle unbalanced. It doesn't look a lot different from the unmodified one, but it's significantly easier to fold. It's still pretty flat. One neat thing here, where the parameters aren't balanced, we get the idea of chirality. Are they curling left or are they curling right? Snails are hermaphrodites. Their bits have to line up. Their shells have to have the same chirality in order to make baby snails. And let's see, on to an unbalanced central angle. This is kind of cool. It has more height, but the whorls, they don't touch anymore. They're separate. And this happens for marine snails. So this isn't off the charts, although the top bit is still flat. I can put it all together and we get something kind of nifty. Nice height, the whorls do touch some. It's a little chunky, but if we decrease the spirality angle, the snail will grow more slowly and be smoother. But wait, what if we add in curves? What if we replace the straight lines with Bezier curves? Earlier, I mentioned curved crease and cardstock. So you can be suitably impressed that I'm showing white snails entirely made of copy paper. Okay, I know you're not suitably impressed, but let me tell you, the origami people would be wowing right now. Although they're such snobs about paper, maybe they'd be closing their Zoom window instead. Anyway, I used copy paper instead of something fancier. So you know you can make these, either by running your own script or by getting a working SVG from me. And I did say that cardstock is easier. It is much easier to do for the curved crease. For the other ones too, I thought. And having done the cardstock and having played with a lot of these parameters, I can make planospiral ones. These are more like the Nautilus. And if you could look really close, which is hard on the camera, it really does spiral all the way in. It's very neat. So what next? I want to do a conch. I have plans for continuing. I'm hoping to make conches. It has proven much harder than I expected. The aperture, the generating function is no longer circular. So that's the talk, a little bit about me, because I think the important part here is that Chris and I host a podcast called Embedded, where we talk about STEAM and STEM topics. It's in all the usual podcast apps, and we really like Mutters as guests. One of the previous speakers, Dan Shapiro, was on our show years ago when Glowforge first was getting off the ground. I think that's a pretty interesting compare and contrast to what he presented today. I'm really easy to find online if you want to chat about being on the show, or snails, or robots, or the half dozen slides I had to cut in order to get this to be even near 10 minutes.
Thanks, Alicia. We are now going to stop recording those presentations.